Picture this. You're on Earth, and you want to visit a star system thousands of light years away. At our current pace, such a journey would take tens of thousands of years, even with the fastest spacecraft we can imagine. But what if there was a shortcut? What if you could step into a cosmic tunnel and emerge on the other side of the universe, skipping all the time and distance in between? This isn't just a scene from science fiction, it's the concept of a wormhole. Wormholes have fascinated scientists, storytellers, and dreamers for decades. They've appeared in blockbuster movies like Interstellar, where they're used as gateways to distant planets, and in countless science fiction novels. But what's the truth behind these mysterious shortcuts? In this video, we're going to explore the science of wormholes. We'll break down what they are, how they might work, and what evidence, if any, suggests they could exist. Finally, we'll tackle the question on everyone's mind. If wormholes are real, when might we find one? This is going to be a deep dive into one of the universe's greatest mysteries. So grab a seat and let's begin our journey. To understand wormholes, we need to start with the basics of space-time. Space-time is like a fabric that stretches across the universe. It's what everything, planets, stars, galaxies, exists within. But unlike a piece of cloth, space-time isn't flat. It can bend, twist, and even form tunnels under the influence of massive objects like stars or black holes. Now imagine space-time as a flat sheet of paper. You want to travel from one end of the paper to the other. Normally you'd move in a straight line across the surface, which could take ages. But what if you folded the paper in half so the two ends touched? By creating a hole through the paper, you've made a shortcut. That's what a wormhole does. It connects two distant points in space-time. The idea of wormholes comes from Einstein's theory of general relativity. Back in 1935, Albert Einstein and his colleague Nathan Rosen proposed a concept called the Einstein-Rosen bridge. This was a theoretical bridge or tunnel in space-time that could connect two different regions. But here's the twist. The Einstein-Rosen bridge was purely mathematical. It worked in equations, but there was no evidence it could exist in the real world. Still, this idea planted the seed for what we now call wormholes. So, what would a wormhole look like? It could be a spherical gateway, glowing with energy, or it might be invisible until something passes through it. The truth is, we don't know. But the idea itself is fascinating and worth exploring further. This is where things get both exciting and complicated. Wormholes are a product of general relativity, but there's a catch. They're incredibly unstable. Let me explain. A wormhole, if it existed, would collapse almost instantly due to gravitational forces. The tunnel would close before anything could pass through it. For a wormhole to remain open, we'd need something called negative energy or exotic matter. What is exotic matter? It's a hypothetical form of matter that has negative mass and behaves very differently from anything we've ever seen. Instead of attracting objects like normal gravity, it would repel them. Theoretically, exotic matter could keep a wormhole stable, acting like scaffolding to hold the tunnel open. But here's the problem. We've never discovered exotic matter. It's purely hypothetical at this point, which means wormholes remain a theoretical possibility rather than a proven reality. However, some physicists think quantum mechanics might provide a clue. For instance, quantum entanglement, the phenomenon where two particles become linked, no matter how far apart they are, resembles a kind of wormhole on a microscopic scale. Could the same principle apply to space-time itself? Some theories suggest it might. Even though we haven't found physical evidence of wormholes, scientists are making progress in other ways. For example, researchers are running simulations of wormholes using advanced computers. In 2023, a team of scientists used a quantum computer to simulate what looked like a tiny wormhole. This wasn't a physical wormhole, but a mathematical model that showed how particles might behave in such an environment. It's a small step, but it's an important one. Other researchers are studying extreme environments, like the areas around black holes, to look for signs of wormholes. Some theories suggest that black holes might naturally form wormholes under certain conditions. If that's true, then the first wormhole we discover might be lurking near one of these cosmic giants. We're also advancing our tools. Telescopes like the James Webb Space Telescope and particle accelerators like the Large Hadron Collider are pushing the boundaries of what we know about space-time. It's only a matter of time before these tools uncover something new, maybe even a hint of exotic matter or a wormhole-like structure. So, if wormholes are real, when could we actually find one? That's a tough question to answer. Think about black holes. For decades, they were just a theory. Then, in 2019, we captured the first image of a black hole using the Event Horizon Telescope. This was a massive breakthrough that showed how far our technology had come. The same could happen with wormholes. Some scientists believe we might find indirect evidence of a wormhole within the next century. For instance, we could detect unusual distortions in space-time that hint at the presence of a wormhole. But discovering a wormhole is only half the challenge. If we want to use one, we'll need to figure out how to stabilize it with exotic matter or develop entirely new physics to keep it open. That's a challenge for future generations, but it's not impossible. So, are wormholes real? At this point, we simply don't know. They exist in the realm of theoretical physics, supported by equations but lacking physical proof. What we do know is that science has a way of turning the impossible into reality. Decades ago, black holes and gravitational waves were purely theoretical. Today, they're part of our understanding of the universe. Wormholes could be next. The real question is, are we ready to step through one? If a wormhole appeared tomorrow, would we dare to explore what's on the other side? Let me know your thoughts in the comments below. Do you think wormholes are humanity's ultimate shortcut, or are they just a cosmic daydream? Don't forget to like this video, subscribe, and hit the notification bell for more journeys into the unknown. Thanks for watching, and as always, keep exploring the universe.